The thing that confuses me the most about percent is finding the percent of increase. Suppose that the store's sales this month are higher than they were last month. Finding the amount of increase is easy, but when I try to find the percent of increase, I'm never quite sure how to do it. Also, if I had to find the percent of decrease, I'd probably have the same trouble.
What you're talking about is percent of change. There are several wrong ways to solve percent of change problems, and often business people get confused in solving percent of change problems. I will give you an explanation so you will understand the percent of increase and the percent of decrease. Hello, I'm Leanne Spar. In this section, we're going to talk about increase and decrease problems. We will cover the following objectives. We will learn to identify an increase or a decrease problem. We will apply the basic diagram for increase word problems. We will use the basic percent formula to solve for base and increase problems. We will apply the basic diagram for decrease word problems, and we will use the basic percent formula to solve for base and decrease problems. Now let's look at the relationship between increase and decrease problems. In a percent increase problem, we always have the original plus the increase equals the new value, in which the original is the base, the new value is the part. For a percent decrease problem, we always have the original subtracting the decrease equals the new value, in which the original is the base and the new value is the part. Now let's look at two exercises in which we solve for rate of increase and rate of decrease. If the part after the increase is $800 and the rate of increase is 25%, then we want to find the base. We know that the original plus the increase equals the new value. So 100% is the original, plus the increase is 25% equals $800. Or 100% plus 25% is 125% equals $800. Base is always equal to part divided by rate. So the base here is going to be the part, which is $800, divided by the rate, 125%, written as a decimal, is 1 25/100. So 800 divided by 1.25 is 640. So $800 is the part after the increase, and it is the result of a 25% increase on a base of $640. Now let's look at the opposite situation, a rate of decrease problem. If the part after the decrease is $1,530 and the rate of decrease is 15%, then we want to find the base, which is the original value. Again, we note that original, subtract the decrease, equals the new value. So 100% subtract 15% equals $1,530. 100% minus 15%, 85% equals $1,530. As we know, the base is always equal to part divided by rate, in which the part is $1,530. The rate is 85%, written as a decimal, 85/100. When we divide that, we obtain $1,800. So $1,800 was our original value, which has been decreased 15%, and we obtain $1,530. Now we're going to do a rate of increase problem, which will almost certainly be a real-life application for you. It involves purchasing a home. The value of a home sold by Thomas Dugali this year is $181,500, which is 10% more than last year's value. Find the value of the home last year. Let's apply the rate of increase diagram. The value of the home this year is 10% more than last year's value. So the base, which is original, is 100%. The increase is 10%. So the 100% plus the 10% gives us 110%, which is equal to $181,500. So the original plus the increase equals to the new value. 100% plus the increase of 10% gives us a value of $181,500. We know that base is always equal to part divided by rate. So we are going to take the part, which is $181,500, and we're going to divide it by 110%. 110% written as a decimal is 1.10. So our base now is $165,000. Last year's value was $165,000. After a 10% increase, this year's value of his home is $181,500. Now let's look at a percent of decrease problem. In a recent test of an automobile anti-lock braking system on wet pavement, the stopping distance was 114 feet. If this was 28 and 75/100% less, then the distance needed to stop the same automobile without the anti-lock braking system. Find the distance needed to stop without the anti-lock braking system. In order to solve this problem, we will draw a diagram in which we will show that 100% subtract the 28.75% leaves us with 71.25%. So as we know, the base is always the part divided by the rate. In this case, the part is 114 feet of the original. So it's 114 feet is the part, and the rate is 71.25% of the original. Written as a decimal is 0.7125. So the base is 160 feet. So we see that 160 feet decreased by 28.75% gives us a stopping distance of 114 feet. In this section, we have looked at increase and decrease problems. We have looked at drawing a diagram to identify the part, the rate, and the base. So now it's time for you to practice some of these problems on your own.